All right, the periodic table has some organizational parts that helps us get some more information out of this other than just seeing a bunch of elements. Firstly, do note that there's kind of this little section of two seemingly sort of disembodied rows. Well, those actually kind of fit like right in here. So you kind of see that 56, 57, 58 carries on all the way across to 71, and then it carries back on to 72 up here. And then same thing down here, 87, 88, 89, and then 90 would fit right there. So those two rows basically fit in that little section. We'll talk a little bit more about why we have them down there later, but for now, let's go and see how this is organized. So this is called the periodic table, partly because this is organized where the rows are your periods. And very easily, it's period 1, 2, 3, 4, 5, 6, 7. Across the top, you have your groups, and I'll kind of just do that generically here. That word is kind of small to fit the entire span of this, but you get the idea. 1, 2, 3, all the way across. We'll speed this along. Done. 1 through 18, all the way across. You also have an alternative name, alternative way of numbering it, which is kind of useful sometimes, and we'll see why later on. But for now, there's also a numbering system that involves a Roman numeral and the letter A. This one will be Roman numeral 2 and A. Weirdly enough, we're going to skip this entire section across the middle. Again, why that is, that's something else that we can look at some other time. But we're going to pick up again at group 13, where we then have group III, 3A. And that keeps going. 4A, that's IV. You have 5A, which is just a V. You have 6, 7, and group 8A. So both methods will be used as a way to refer to the specific groups. And that's kind of like an old or a more consistent way to refer to elements on the periodic table. So we have groups and we have periods. There's two different ways to number the groups. And one of those ways kind of skips this entire section. All right, let's go and look at some other things. So one of the important things, and usually never presented to you, but is a nice little memory or a nice little thing to kind of visualize, is that I'm going to draw this little zigzag line going across here. Effectively, this zigzag line is going to be a separation of metals, metalloids, and nonmetals. Everything to the left, right, this is worth knowing, everything to the left of this zigzag is basically a metal. Everything to the right of this is considered a non-metal. Hopefully you kind of recognize some of the elements. For example, just picking a random one, nickel, you have sodium, you have gold. Those are all metals. So to the left of it, you know the metals. To the right of it, those are non-metals like oxygen, nitrogen, and such. Furthermore, let's actually kind of break down exactly what this line represents. So effectively, any element touching this line, right? Any touching, not the corners, but actually touching the line, those elements are considered to be metalloids. So these are elements that kind of have properties of both metals and non-metals. We'll get into that later on, but know that those are your metalloids. Now, there's a couple of exceptions. Before I do, let me make sure I point them out. So elements like boron, B, Si for silicon, Ge for germanium, Sb for antimonate. These are the ones that are considered metalloids. So silicon, Ge, As, Sb, T, so on and so forth. Now, there's two important exceptions, and they're the ones I'm just going to highlight, just kind of mention, is Al, aluminum. I think you know that that's actually a metal. You've seen aluminum before. That's a metal. And also polonium actually also ends up being a metal too. So those are only two important exceptions. Otherwise, everything else is considered a metalloid that is directly touching that zigzag line. All right, so once again, metals over here, non-metals over here, and then with some exceptions, the zigzag line refers to our metalloids. All right. Now, within that, with this, there's also a couple of other designations, and I'll kind of use some other colors here to designate exactly what I'm looking for. Are these columns kind of have elements that have some old names that have stuck around? For example, this first group right here, right, I'm going to kind of box them in here like this. These elements, you can probably do a better job than I can, but these elements here, these are considered or have an alternative name called alkali metals. That's A-L-K-A-L-I, metals. So these are metals, but then they have the specific designation of being called alkali metals. That goes there. You also have this one to the right of it, and I'm going to kind of box them as well. These are considered your alkaline earth, A-L-K-A-L-I-N-E, and then earth metals. Right? So yeah, these actually have kind of an alternative name. Notice how I've left off the H up here. H is not a metal, even though it's kind of in this area. H is actually considered non-metal, so no, that's sort of excluded in that discussion of metals. But specifically from lithium down, those are your alkali metals. From Be, beryllium, down to Ra, radium, that's considered a bunch of alkaline earth metals. Let's go over to the right. Let's go and see what's going on here. From He all the way down to Rn. And kind of ignore this UUO because it's not really an element that we're ever going to concern ourselves with. These elements here are what we consider to be noble gases. You may have heard of these before, but these gases or these specific elements are known to be very stable, don't really react with a whole lot, hence noble. All right, let's see what else we can do. To the left of it, we have starting with F all the way down to just I, and some people will maybe include the AT, the astatine. That's not as important. These in gray, I'm going to kind of draw a little arrow from here. These are actually called our halogens. So again, this group of specifically 4 elements are halogens. To the left of it, we'll include one more little designation, and we'll do this in red, repeated color. These from O down to S and SE. SE, again, not touching the actual sides of the zigzag line, so it's still technically a nonmetal. These 3 elements are what we call chalcogens. That's CHALCOGENs, chalcogens. All right, so those are the kind of names that we have for very specific columns of elements. Let's go and see what we can do in terms of just bigger, broader ones that don't necessarily stay within those columns. So if you look in the middle, we kind of looked over or kind of glossed over a few. This is orange here. So basically everything from here, all of these elements right here, these are going to be considered our transition metals. Right, those are transition metals. Transitions, TRANSITION, transition metals. And that's in the orange there. And then we kind of have these like sort of no man's land elements under there. These right here, starting with gallium, all these down here, kind of sort of catty corner, not exactly touching the black line. These are, there's not really a specific name for these. A lot of times they're kind of just lumped in as other metals. We'll refer to them as stair-step metals or the ones that look like they're kind of underneath the stair-step of this black zigzag line. So stair-step metals. That way you kind of refer to them. There's no official term for them, so we're just colloquially call them stair-steps. All right. Across the bottom now, these 2 rows that we sort of mentioned earlier. So as we mentioned earlier, right, La, lanthanum, this is the element that comes right before Ce, 58, 57, 58. And so this series on top, right, this row across the top, these are called lanthanides because La is the element lanthanum. And so these are again called lanthanides. Let's spell that L-A-N-T-H-A-N-I-D-E-S. These are called our lanthanides. Underneath it, you have another row of elements kind of in a similar vein, right? This is kind of a continuation of 89, so 90 again picks up after 89, and it's going to be kind of named after AC. AC is the element actinium, and therefore we call this row right here, and then I've kind of got this light blue, these are called our actinides. So sort of in the same vein, actinides. That's a terrible handwriting. Let's try that again. A-C-T-I-N-I-D-E-S. Let's get rid of the relics of a past attempt at spelling. Actinides. All right. Now, together, the lanthanides and actinides, we actually have a specific term for them. It actually goes off of what I highlighted in orange earlier. So the lanthanides and actinides, these 2 together are what we call inner transition metals. Right, so they're metals, but they're kind of like an inner part of it. There's not really an outer sort of counterpart to it, but there you go. Now, there are some other elements here that aren't really kind of a part of a specific group. For example, the N and the P here. And same thing with carbon. We're not really too worried about it. But sometimes you also hear like elements that are associated under the column as like elements in the nitrogen group, right? So nitrogen's at the top of the column. Everything else underneath it is considered part of the nitrogen group. All right, that basically takes care of your periodic table and how it's organized.